We could able to identify the significance of data stream management system when comparing with the data management system, where the data model is compared to the data streaming database management system. It is a streams and permanent updatable relations. Okay, it's a stream, continuous stream. But data storage is concerned, the permanent relations are stored on the disk. Streams are processed on the fly. So when the data on stream, we process it, we'll try to get the query answer for the query. The query is, we use SQL language, and we have different languages, database management languages, like create table kind of thing, insertion, manipulation, all that is possible. Inserting, updating, deleting data, retrieving data is one-time query. So whenever the query is executed, you'll get an answer. Whereas here we got the continuous query, as well as we call it as, the concept is called windowing. Windowing, nothing but actually we make a window on the stream in a specific window. So based on the windowing, we'll also try to execute the query, right? So this is a continuous query language we use to get the answer for our query. And performance concerns, a very large voluminous data, whereas the data are completely stored in the data storage, secondary storage space. Whereas data stream management system, we use optimized storage resources to deal with several streams and several queries, and ability to face versions in arrival rates without crash. So look at the time, the volume of data coming in. Okay, so the main differences between the DMS and DSMS, with this figure, with this table, we could able to identify the significance. It's a persistent data, this volatile data streams, where so archived data cannot be done anything with only limited query could be accessed with a very powerful tool. The random access, DBMS is random access, whereas a sequential access, so one-time query, and DSMS is a continuous query. Theoretically limited secondary storage, whereas here we have got limited main storage at which we use specific query. There are two ways we get this query. One is continuous query language on stream data, and some specific data is stored at a limited main storage to for further process. Only the current state is relevant with reference to DBMS. Consideration of order of input, so, and relatively low update rate, potentially extremely high update rate. So little and no time requirement for all the process, all that assumes updated inaccurate data, outdated and inaccurate data, real-time requirements, and DBMS assumes extract data. You will get whatever the query, the precision will be very high, whereas planned query processing, we get a planned query process, we do it and execute it. Here it is, you cannot get the very accurate data. This some extent, so it's because it's a continuous streaming data at which we could able to get the, cannot spare, we'll try to optimize the query, try to get the possible outcome. Variable data arrival and data characteristics, and there are different evolutions happen during this in the DSMS. So it could be classified into query based and rule based as you know, rule based is like similar to your association mining, where you get a rule. So for example, for example, who are all the prosperous customers? Like if the persons who earns money, who earns 30%, 30,000, and with the mail, some rule, right? Based on the rule, we do apply the outcome, right? Some we do apply the rule, right? So the query based. So there are the the color shade itself tells us. So there's evolution that happened in all the phases, and Red Hat and open source uh, query languages is also there. And so what are the challenges of stream data processing? Multiple continuous and rapid time varying ordered streams, and main memory computations. So minimum storage, main memory computations is done. Query are often continuous, evaluated continuously as a stream data arrives. Answer updated over time. Queries are often complex beyond element at time processing, beyond stream time processing. Beyond relational queries, multi-level, multi-dimensional processing and data mining. Most stream data are at a low level and multi-dimensional in nature. We'll continue with the different methods of data stream processing in the next class. With this, I wind up the class. So I hope you could able to understand the concepts in well advance. So I'll also share the PPT along with this. So kindly go through it and refer some other material, and also refer the big data computing from Swayam. Have a nice day. Thank you.